Thank you all for joining, and of course, thanks to our panelists, thanks to Madeline and the team at EFI, and also thanks to Toyota Research Institute for supporting the workshop, whose findings we will be discussing today. As you all know, geological hydrogen, whether natural or stimulated, is really one of the few, I would say, truly possible breakthrough pathways to an affordable clean energy future. Real game-changing potential, and that's because it could be, some estimates have geological hydrogen priced at less than $1 a kilogram, quite competitive or even less expensive than hydrogen as we produce it today, with considerable CO2 emissions from natural gas through steam reforming. It again can have a very low carbon footprint. It could require substantially less infrastructure than is being talked about for produced hydrogen, green or blue or your favorite color. It could have distributed sourcing, for example. It's really a very exciting area to pursue, but of course there are major open questions in the geological realm, as well as in the policy and regulatory realm. I think the geological issues ultimately will be decided in the field, whereas the policy and regulatory issues are, we would posit, areas that we need to really examine today, not in series after we have the geology, let's say, resolved, in series, so that if the breakthrough is as great as is hoped for, we can be ready to dive in as soon as possible. Clearly on the policy and regulatory side, there are not only many issues, but a lot of inconsistency today in terms of how, for example, different states approach the challenges of geological hydrogen. We'll hear more about that today. And earlier this year, and participated, the EFI Foundation held the workshop that we'll be discussing today. Participants from industry, government, academia, and the report on that workshop was released last week, and the panel, Madeline and the panel, will be discussing its findings and where we go from here in terms of the implications for developing geological hydrogen. Again, assuming the geology works in our favor. So with that, again, thank you all for coming. I'm going to turn it right over to Madeline to start discussing the findings, and then she will pivot to our terrific panel who will elaborate on that. Madeline?
Thank you very much, Ernie, and good afternoon, everyone. I'm excited to join you for today's webinar and to walk you through key insights from our report titled Exploring the Future of Geologic Hydrogen. This report is the culmination of a full-day closed-door workshop with experts from across science, industry, policy, and others to assess what it would take for geologic hydrogen to move from sort of a curiosity to more of a commercial reality. And today I'll speak briefly to a few core messages from the report, focused specifically on the enabling environment for exploration and the kinds of policy clarity and coordination that can help the U.S. to lead in this space. Let me start with 6 key takeaways from the workshop, which you see on this slide. First, participants broadly agreed that uncertainty is huge, but the potential is enormous. Even if a small fraction of the potential can be recovered, say 2%, it could yield somewhere around 100,000 megatons of useful hydrogen globally, which, to put that in context, is enough to supply the world's current energy needs more than 18 times over. But the U.S. has not yet validated most of its subsurface potential, and only a handful of exploration wells have been drilled to date, which is why that uncertainty remains. Second, we heard that clear, streamlined rules will expedite exploration. Without this clarity, developers face substantial barriers to permitting even early-stage exploration wells, and we'll talk about that more in a moment. Third, market variability depends on co-locating demand and production, much like other forms of hydrogen production. Participants stress that economic case for hydrogen is geography dependent. So exploration needs to be focused not just on where hydrogen may be found, but also where it can be used or transported cost effectively to off-takers. Fourth, federal-state coordination is a critical foundation. This balance is especially important given the diverse geologies, regulatory landscape, and resource ownership patterns across different basins. And we're also going to talk about that more in a moment. Fifth, public funding must de-risk early-stage investment. Many attendees emphasized that exploration wells cost millions of dollars to drill, and few companies have the ability to drill them at scale without some form of public co-investment or early-stage support. This could come in the form of federal matching grants, data sharing initiatives, or DOE-led exploration pilots, similar to how geothermal exploration has been supported. And sixth, there's an urgent need to build support through collective action and public messaging. Participants agreed that geologic hydrogen lacks public awareness and policy visibility, and that a more coordinated communication effort is needed to build trust and enthusiasm, particularly in those communities where drilling might actually occur. Of these 6 takeaways, I'll spend the next few minutes focusing on just 2, the need for clear, streamlined permitting, and the importance of strong federal state have primacy for underground injection control permits, which can facilitate faster and more predictable permitting approvals. And we've found that NEPA exclusions may be applicable for early stage wells under certain conditions, which could also help to streamline and expedite the permitting process to allow for more of those shots on goal. Next slide, please. One of the strongest messages from participants that we heard was the need for federal-state coordination to enable early progress. Several developers emphasized that they aren't necessarily chasing the shortest permitting timelines, they're chasing the most predictable ones. And that predictability comes from clear jurisdictional roles, early interagency alignment, and consistency in data between federal and state authorities. So the report outlines a model in which states take the lead on permitting and project oversight so they can tailor that to their unique geologies and community contexts, while federal agencies contribute more with technical expertise, baseline mapping, subsurface modeling, and creating that consistent data standard. This model recognizes that exploration will go further faster if it's grounded in federally supported science and implemented through state-level regulatory pathways that are responsive to those regional conditions. Ultimately, the takeaway was pretty clear. What developers need most is regulatory certainty, not just speed, and that certainty can only really come from that well-coordinated, multi-level governance framework. So to close, this is not a call for major public investment. Actually, participants estimated that it would only take $500 million to catalyze the next phase of geologic hydrogen development, which is small, relatively speaking. So this is a call to harmonize our regulatory oversight and design those permitting pathways with some funding for basic science and exploration. And if we do that well, we'll know pretty soon whether this is a game changer and how the US can be a global leader in that game. And with that, I'm going to introduce our panel, moderated by Doug Wicks, who is the now former program director at ARPA-E, where he focused on waste to energy technologies. He will be joined by Mary Haas, a partner at Breakthrough Energy, who has over 23 years of leadership impact spanning industrial gas and climate technology. Kristen Delano, head of government relations and public affairs at Koloma, where she drives legislative strategy and coalition building to advance natural hydrogen exploration and innovation. And Drew Nelson, the deputy director of the Nebraska Oil and Gas Conservation Commission, who oversees regulatory and operational aspects of the state's energy sector. Take it away, Doug.
Very good. Thank you for having us, Madeline. I will jump in and ask the first question of Doug. So Doug, having had a front row seat to this administration, how do you see geologic hydrogen fitting in with the current administration's goals and priorities?
Thank you, Mary. Yeah, thank you, Mary. Make sure my mic was on. I see a clear fit for the current administration's theory of or approach towards energy dominance, and the real focus they have is on primary energy sources, whether it's oil, gas, geothermal, or nuclear, as being clear things. And one of the best advantages of geologic hydrogen is it's really going to leverage the oil and gas infrastructure and expertise that the country already has. And so it falls into that idea, I guess, that one could summarize by drill, baby, drill, because it fits right into there and uses the same workforce and equipment as we go forward. And thank you for jumping in, Mary. Good to see you. So I'll start moderating now. And I'll ask the first question to Drew. Can you share why Nebraska is interested in geologic hydrogen and why you've been involved with the development of policy issues such as from the Energy Future? And what can the government do to drive this faster?
Sure, thanks, Douglas. Appreciate the question. First off, we, as we all should be, we should all be paying attention to new opportunities for, additional energy production to meet the growing demands our nation and the world has. So from that standpoint, obviously, Nebraska is interested in contributing. We have a current project in Nebraska. A well was drilled in 2019, completed in 2019. And it's currently down for maintenance, but so we have a project going here already. So we're hopeful that more projects will come up and that something will work out well there. As far as the federal government and state interactions, a couple points on that. I really think that it's important that the states are kind of the drivers as far as the regulatory processes. And that's because things tend to move a little bit faster in state governments. And also the people on the ground in each state have a unique perspective and understand of the challenges due to their own regulatory framework and structure and timelines. And so I think that it's really important to recognize that the states should lead in that aspect, just kind of like Madeline was explaining earlier, that the states are kind of best in that framework, and then the federal government, can be assistive in supporting some of the some more conference opportunities, maybe to talk between the states and the federal government. We have a couple agencies where the producing states get together. There's an organization called the Interstate Oil and Gas Compact Commission. We meet a couple times a year and talk about these types of issues. To this point, geologic hydrogen hasn't been one of the big main topics at these kind of conferences. And I think there's a good opportunity for maybe some of the federal agencies that that are also partners with that compact commission, the DOI, DOE, EPA, to get involved and maybe try and sponsor some talks at some of those conferences. The states that are involved in the IOGCC generally can make it to those conferences, but there's other states that are not members of that, and if there's going to be hydrogen exploration done in those states, it would really behoove them to be able to come to the conferences, and sometimes their state regulations don't allow them to attend conferences, or at least to have the funding to go to those type of conferences. So that's an area where I think there could be some contribution from federal government as well.
Okay, thank you, Drew.
You bet.
Quick question for you on a regulatory standpoint. For the first exploratory well that went into Nebraska, how did you regulate that? Under what type of well classification?
Good question, Doug. Yeah, so we handled it as a Class 2 UIC well. We permitted that well as a natural gas well, and we were able to do that because of how our definition of, and it's a loose definition of what natural gas or gas is. And so that's going to vary state by state. That's where some of the complexity comes in, is that the definition of what geologic hydrogen is and what natural gas is not the same. It's not standard. So that's an area where some work could be done. But us as an example, I mean, we have it defined in a loose enough fashion that it allows us to just call it a natural gas exploratory well and drill it under our current Class 2 regulatory authority.
Okay, thank you, Drew.
You bet.
Mary, now a question for you. A lot of money is going to be needed to fulfill the potential of natural hydrogen into new space. And there was some discussion of federal money as being a possible, but really, what are the challenges and barriers to getting venture investments, and then the follow-on funding required really for site development?
Yeah, absolutely. So for those who are not familiar, Breakthrough Energy is a venture capital firm. We invest in early stage technologies that can have a breakthrough impact on the future of energy abundance in a clean profile. And we've been tracking this space over 10 years. And have monitored over 100 companies and teams globally. So to Doug's question, absolutely, we see this as a space consistent with venture capital. We've made several investments ourselves. I will say in the US that the work done by the Department of Energy and the USGS absolutely has played a catalytic role in attracting private capital at this early stage, as we have companies beginning to drill and doing field work to determine where to drill. The next stages, as were mentioned, to get both more shots on goal, but to really unlock the potential of what is potentially a massive energy source and raw material for many manufacturing processes in the US. The sharing of risk for technology such as this, and geothermal was mentioned, which is a great example of how private partnering with government support on de-risking had a major catalytic effect. And so we do see a potential inflection point if the government can continue its catalytic role in maintaining the U.S. in a dominant position in this area.
Good. A question I'm going to ask yourself and Kristen is, what's the impact, do you think, of current tax changes that are being considered around the big beautiful bill regarding subsidies?
So I think that broadly speaking, and geologic hydrogen included, the changes being contemplated have caused venture capital to look outside of the U.S. maybe a bit more than the focus was previously. Again, all about certainty, clarity, and de-risking partnership. And so, I'm hopeful that there are ways for the U.S. to maintain its lead, but there certainly is work to do in terms of all of the factors we just listed in attracting that private capital.
Okay, thank you. Kristen, I want to you. Koloma has raised a lot of money. I can say started by Breakthrough Energy Ventures seed investments in the area. And so what kind of technical advancements do you see as being really important to fulfill the expectations of your investors and attract that follow-on funding?
Yeah, no, I appreciate the question. So I think the technical advances that are super helpful that the federal government and state governments can bring to fruition private investment is doing deeper studies, collecting more data, taking the information that already exists, and bringing it to higher resolutions. Just kind of de-risking things of once there's exploration and I'm not going to say if, I'm going to say when geologic hydrogen is discovered, that there's already data and studies along distribution outside, past that point. And what that does is then it also incentivizes the states that, I've been fortunate enough to be going across the country working and educating different states. If that were to happen at the federal level and investments in labs and situations like that, then the states are a little bit more inclined to do the same thing with information that the federal government has collected in surveys and data, and they take it to the next stage there. And then what that allows, companies like Koloma and others to do is then run with that technology and that research and data and take it to the next level, which would then bring exploration and then hopefully a future discovery closer and closer, to happening near term.
Yeah. Kind of another question coming back to your role here in DC, the DC area. And we've had several events up on Capitol Hill that have involved Koloma. What sense did you get from either the Senate or the Congress as to their interest in natural hydrogen?
Yeah, I'll have to say, being a longtime government affairs person that's gone across several industries, advocating and lobbying for geologic hydrogen has by far been the most bipartisan and exciting. I think the highest lift though has been education, right? So once you sit down with a member of Congress and have the opportunity to really explain what it is, how it works, that it's a primary energy source, the value that it can bring to the energy needs, that's been great. I mean, last February, we were able to get a hearing on the Senate side specifically about natural hydrogen, and you could see across the aisle that it was supportive. And we've got lots of requests from, Senate and Republican staff and outside groups to learn more and ask what they can do. Unfortunately, we just haven't quite gotten over the goalpost, for kind of incentive funding and credits.
Okay. You mentioned it's bipartisan. Does it go across the country? I mean, is this something that, it's just oil and gas states and, or do you see it in other locations?
Yeah, I'm seeing it in other locations too. I think folks are starting to realize we've got some energy crisis. We are in an energy crisis and we've got more coming down the road. And a lot of states surprisingly and really hopefully are saying we can't let perfect be the enemy of good here. And they're realizing, with low CI, low land, low water, but also the oil and job transition, also creating jobs for low income workers and bringing a new energy economy into different parts of the country. I am finding it to be very bipartisan. But like I said, the highest lift right now is just the education portion.
Okay.
Doug, I'm going to jump in with another question for you. You and I have both looked pretty closely at the techno-economics in modeling these potential reservoirs and exploration types. The Department of Energy publicly shared analysis of the potential of even less than 50 cents a kilogram up to $1.50 a kilogram under certain conditions. How confident are you in that possibility, and what are some of the key uncertainties on cost?
I'm confident enough to say that we're in the ballpark and that we're cheaper than electrolysis hydrogen significantly. And these models were developed within RPE by a summer scholar coming out of Stanford University, and really took hard numbers that come out of the oil and gas and enhanced geothermal spaces. We got great sharing of information. So, the actual drilling costs and the production costs and site development, as well as exploration, are pretty solid numbers that go into this. There are some really great unknowns within this, though, that will affect that. One is how do we determine the resource of the reserve in the subsurface? So how big is it? You need to have a certain amount of production to go, and that tells you your overall production that you'll be amortizing against. The other part comes back in the stimulation side, that how fast can we make the reaction, and how much of the rock or the ore can we safely react in the subsurface. And those are the two major drivers there of the uncertainty we have. And I'll say from the stimulation side, there's lots of work being done that shows we can control the reaction rates. It looks like we can enhance it by large amounts if we want to stimulate it. On the exploration side, or the quantification of resources and reserves, as I like to tell everybody, pretty much wherever you drill, you're going to find hydrogen. The question comes back is how much? I mean, just finding hydrogen doesn't mean anything, because if you go to your banker and say, oh, I have hydrogen, they're going to look at you and say, how many tons per day and how many years? And right now, one of the biggest challenges, we don't know. That kind of discusses, sums it up. So I am confident. I think what we're looking at for the real uncertainty is going to be an engineering problem. And, once we let loose our fine engineers on it, they will solve those problems. Thank you for that question, Mary. Drew, I'm going to kind of come back to the collaborations with other state agencies. You mentioned the interstate oil and gas compact as a way that you collaborate now. How do you see the states kind of collaborating, to develop the source and share information about geology? You have the Association of State Geologists. Is that a route to go through? Is this something that the government or a nonprofit needs to set up something equivalent to the Interstate Oil and Gas Collaborative Compact? Excuse me.
Yeah, so where do I want to start on that? So IOGCC is currently like the main venue where we're intrastate, like or interstate, excuse me, states get together and talk about these type of issues. And like I said, it hasn't been a big topic at any of our conferences to date, and that's something that probably should change. I think it's great that Kristen, I didn't realize you were going around and talking to states, and I think that's a terrific mechanism as well. I think that the awareness in the state regulatory framework it's not a primary initiative right now. It's not something that people are readily thinking about, looking into. It's one of those issues that it comes up and people talk about it for a few minutes and what do you know about it, and then it kind of drops off. So I think that there does need to be some impetus. Perhaps my suggestion of federal agencies working to get involved with like the IOGCC and propose some additional topics of conversation at those conferences would be good. And then on the states levels, I would highly encourage states that don't have Class 2 primacy to be looking at that as a possible path forward for these type of projects. I think it's going to be for us. It worked out very well, and of course I can only speak for how things go at Nebraska, but for us that was a clear mechanism for us to be able to allow a project to begin. And the other thing is that states need to start investigating their framework, their rules and regulations on hydrogen exploration, and if they're not adequate, to start looking at making them adequate. I think there's a lot of work to be done, but I'd reiterate that I truly believe the fastest and probably most I got to think of the right adjective I want to use for it. I just think the best way to handle the regulatory issues is probably having them done by the states, understanding that state to state the regulations are going to be a little bit different, the methods are going to be a little bit different, the time lengths are going to be a little bit different, but the expertise is there on the ground for how regulatory or how regulation is done in each individual state. So did I get to your question, Doug?
Yes, you did.
Okay.
Hey, Doug, I have a quick kind of tie together of two questions. You had asked, what the federal government can do when it comes to pushing ahead technical advances. What I think would be very helpful, Andrew, to tag on to your point as I'm speaking with states, is that the more studies and white paper and research that they make available, I'm out there and very fortunate to be talking for Koloma, but also, on behalf of a new industry where there's not a lot of government affairs or PR folks, where that's, are my initial job. And so coming off as just Koloma and not the industry, it would be great to be able to have resources of research from labs or different things that I can present, or Drew, that you can present to your folks, that really does show the science and the end uses and the value, and it not just look like a company, right? Like a company investment for ourselves, but really something that is going to be the rising water. I find that's something that we're really short on, to be able to present in these conversations.
Thank you. So that's kind of building on that question. you were talking about the states, and what about the reception there? Is this something that you push as being a job and revenue potential for many parts of the country that don't have energy development in them now?
Yeah, absolutely. Yeah, that is a large conversation that that a lot of governors all the way down to, county officials are very interested in. They want the resource, they want what's great for the entire country, but it also matters what happens in my backyard. How is this going to affect my home and my family and my community? There's a lot of places throughout the country that would love to participate in the energy economy and have more jobs and be able to bring up their median income level with the type of oil and gas wages that natural hydrogen could bring that way, the infrastructure, the pipe fitting, the electrical folks, all of those type of things. But then also the revenue, the tax base, but then also as we're working with local landowners for exploration, right, that there's value in it there for them as well. And so the jobs piece, the energy piece, keeping their energy costs lower, especially if data centers are looking to plug into the grid. You can imagine what that would do to the cost of energy. But what we're finding with these, local conversations is we need to go in early and be transparent, talk about safety, understand their concerns, and be available to answer any questions. But the reception's been great. Just alongside, again, the education that's so necessary.
Thank you. Mary, Breakthrough has been active globally in this space. What are you seeing around the world, and what does this mean to the U.S.?
Yeah, absolutely. I think the US has quite a few things going for it. Our national labs, extremely strong, have the kind of resources and have contributed to subsurface development of both oil and gas and mineral resources in a very substantial way. We have a lot of the rock type and geology type that is amenable to this kind of resource. I will say that global activity has really picked up. Just a couple of notable factors. The Philippines recently, I think towards the end of 2024, had the first public auction for land associated with geologic hydrogen. They got global attention and activity in terms of bidders in that process. I think we've tracked 11 or 12 countries who have proactively changed their mineral rights, similar to what Drew described in terms of, okay, where would geologic or natural hydrogen fit in the most readily? Can it be bolted on to fossil fuel resources? Does it fit under a mineral code? Russia is one of the countries that has done that proactively. I think we would really like to see the US maintain its lead here. The kind of geology that will lead to the lowest cost, absolutely present in the US, very likely present in Russia, very likely present in China. And as we can see, this is not happening just within the boundaries of single countries. And so I think between US global companies, investors, Chinese global investors, and companies, we are likely to continue to see increased activity, whether it is identifying and getting exclusivity to acreage, whether it is really redirecting the natural resource national labs of those countries into substantial investigation. The US, in my personal belief, has the lead today and would very much like to see it keep the lead, and why we're here talking today. We are very bullish in this space based on everything we've seen in over 2 years and getting very close to the science and the bottoms up kinetic work that's being done in reservoir modeling. We really do think this is a breakthrough. And with those more shots on goal, it is going to be figured out. And so, who really accelerates in adding this to their energy profile is an open question today, but one that the US and other countries can impact.
Okay. So kind of a quick question or a quick set of comments. So I'll let each of you make a comment to close, and then we'll go to questions. See if we have any questions from the audience. I mean, if there's anything you want to share, Kristen, Mary, and Drew, as final messages for EFI and the attendees.
I guess I would just say, I really appreciate the port and EFI taking the time and really recognizing the potential in geologic hydrogen. And just to echo, Drew, Mary, and Doug, your comments, it's going to take all parts, all, government sectors, states, industry to come together and really move this forward. I really don't think it's an F. I think it's a win. It's just going to take the political will to get there. And I think we can do it.
I would just add that we've spoken about the benefits of being able to redeploy resources, being able to leverage experience, having drill rigs available in the US where they're very sparse in other places of the world. At the same time, this is not as simple as taking an oil and gas playbook and handing it to a developer and using it as is. So there is innovation to be had that will be part of the race to deployment and to leading the way in this new space. There's innovation to be had in methodologies, modeling, subsurface detection, reservoir generation, and maybe hasn't been said yet, but we're talking about kinetics and reaction of hydrogen being formed on a time scale of months, if not weeks, if not years, which flips so many paradigms on their head when you think about oil and gas that take millions of years. So as an innovation-based investor, we're really excited about the innovation potential here. Innovation is something that the US does very well, and encourage others to get involved and help drive this forward.
It's tough to add much to that. I think you've all summed things up very well, and I guess my comment would be ditto.
Okay, good. All right, we have some questions in the Q&A. Panelists, if you look at there should be a little box down at the bottom that says Q&A with 21 questions in that. We can answer some as they go through. I will start out with talking to Avtar Binning and say that the US government currently only has a small exploratory project in the area, and that has involved researchers from France. And so there is potentials for international collaboration in these. Okay, a question for Kristen from Joe Spees. I'll let you answer this one. So it's looking ahead. Once hydrogen is extracted and processed, what are you going to do with it? Are you just going to turn around and re-inject it in the ground?
Yeah, once we find it, we'll be like, okay, we found it, next project. So natural hydrogen in uses, sustainable aviation fuel, a couple of byproducts, ammonia, helium, long haul trucking, long haul, shipping, lots and lots of things. But what we think is the next step will be pipelines will be way down the line, decades down. So it'll, be trucked, put into electrolyzers, taken to data centers, but most likely it'll be co-location, which is why a lot of states and localities are really interested in it. So if we find it in a place where farming is abundant, and right now we're, importing billions of tons of fertilizer, we'd be able to bring down that cost, co-locate, bring down the cost of food, situations like that. Sustainable aviation fuel, but it's basically like oil and gas, where the industry came to where the resource is. So that's kind of what we see once we find it. The next steps being is creating that infrastructure to co-locate.
I'll make one quick build based on what I think I heard in the question. And so the idea of underground geologic, I'm sorry, the idea of hydrogen underground storage caverns typically is coupled with electrolysis, right? Where you don't have a 24/7 operation and you need buffer storage. If you think about a natural gas well does not have buffer storage. It doesn't have tanks, it doesn't have a secondary reserve. You turn it on and off at the time that you need to produce, just in the flow. And so I would think of, just in terms of the idea of storage and flow capacity, would think of it closer to a natural gas well than electrolyzers.
Yeah, correct.
Sure. Mary, I'm going to toss you a question since you, I think, brought it up, and this is from anonymous attendee. And it's saying, is the U.S. leadership in geologic hydrogen real or assumed? And where do we have the advantage and where do we play catch up?
Yeah, and so definitely caveat that that is my opinion personally, that we currently have a bit of an edge. I will say that from what I know, the most drilling activity, as far as I'm aware, is taking place in the US today. There is nothing like the data that is generated from actually drilling and getting into the ground. So I think that does give an advantage. I will say that the money that went to fundamentals on especially kinetics, I think you can correct me, Doug, $18 million out of ARPA-E on fundamentally on stimulated hydrogen production. Those projects are in progress. To my awareness, there's no other country that has put that kind of catalytic money into this space in terms of developing the fundamentals yet. I think on the catch-up piece, I do think that in both of those areas, we have multiple countries who are now advancing in terms of drilling activity taking place in a couple of locations, in terms of some government research funding, government mandated survey. I would say the place we have the farthest to catch up, and again, this is purely opinion, Kristen and Koloma can comment if it's accurate or not. There are countries that are substantial pre-competitive data available, publicly available. If you look at Australia, there was an effort to map the entire country with, electromagnetic gravity, kind of lower resolution data. There have been studies that when a country spends money on pre-competitive mapping data that they make publicly available, the returns are typically large in terms of, whether that is gold and critical minerals or whether that is these kind of natural resources. And so the US, based on what I have seen, in my opinion, I would say we're behind in what kind of pre-competitive data is available. And that is attracting developers to certain states that are in a better position when it comes to that pre-competitive data than others that are really lacking.
Yeah, Mary, I absolutely agree with that. And that's where I think the investment, the federal labs can do across the board is bringing the US up into a competitive nature publicly available information and mapping. And then what private industry companies like Koloma can do is use that and then take it to the next phase, so much quicker and expand exploration exponentially faster. The other, competitive advantage that some of the other countries have is, we have local land rights here, which is fantastic. But at the same time, we're leasing private lands acre by acre by acre, which can take a lot of capital and time. Whereas other places around the world, like you had mentioned, the Philippines or Australia or, other localities, there's large tracts of land available for exploration without the block by block kind of method.
Okay, thank you. Drew, a question for you from Janie Thompson, and it's about Class 2 primacy. And she's saying, is there an argument to be made that permitting geologic hydrogen exploration should be even simpler than what's required for Class 2? Do we want to have a lower risk? If there is a lower risk, do we want to have an even simpler process for permitting?
That's a great question that I don't necessarily have the technical expertise, in hydrogen development to answer for sure. My gut instinct is to say that probably not. I mean, I think the Class 2 standard is not a overly burdensome bar to reach, but that very well may be the case. I'm just not familiar enough with the differences in producing hydrogen compared to oil and gas. To me, it seems almost the same as a gas well, without some of the hazards. That's the best answer really I can give on that. That's one that I don't know for sure.
Okay. Kristen, a question for you. Since you guys are putting the rotary truth detectors in the ground, what is Koloma looking at as a real development timeline? Is this going to be years or decades? And what could speed it up? So have you promised Vinod Khosla that, decades from now, he's going to see a few dollars, or is there an expectation of realization earlier?
Yeah, I mean, it's nascent, it's cutting edge, it's, science is still coming along. But we see it as handful of years away, not decades and decades away. So that's really exciting, but no promises, right? There's still a lot to be done. It's still nascent and new, but the data is looking to be a handful of years away. What is going to take to speed that up is more exploration companies, right? Rising waters. So although Koloma, we're very fortunate to be well funded and being able to expand exploration and operations a lot and being much more surgical. It's going to take a lot of us out there, a lot of investment doing the work, because the geologies are expansive, the country is expansive, and so more hands makes more work.
Okay. Another question coming from Doug Hollett that I'll put to Kristen and Mary. And do you believe that having open or shared data test sites would accelerate the sector, aside from just providing lots of information, having a site to go to actually do the testing?
I think that the question around shared data is a really excellent one. And that answer comes all the way from, again, the availability of pre-competitive data and the ease of accessing that pre-competitive data. But then also comes to, for example, the combination and the synthesis of all of the ARPA-E data that's taking place in terms of kinetics, and how to get that into forms that are essentially those white papers that tell us what we want to know about many places where rock samples are being measured in the lab. I think in terms of a shared location, certainly it is, from my perspective, worth discussion and looking at what has been done in geothermal, right? That was very targeted in terms of the kind of common questions that allowed advancement to happen more rapidly, but still allowed private companies to maintain their really key competitive advantage. And so I do hope we see more discussion around public-private partnership and learn from the lessons of geothermal and other areas.
Yeah, Mary, completely agree. Learning lessons and seeing how it worked and how it was advantageous, but also understanding, right, like we're still a proprietary information and it's still kind of like the next gold rush in a sense. So kind of respecting both of those boundaries, but trying to get the job done however we get it done.
Kristen, that'd be a question for you. Is there a prominent lobby or advocacy group in DC regarding natural hydrogen, or are you out there as the lone voice?
That is a great question. So we started our GR function because we're lucky enough and fortunate enough to be able to do that just because of the funding opportunities. We're grateful to be involved in other associations, like FCHEA and VCSE and CREP. And, I can just rattle them all off who have taken us in. But so far it has been, kind of a, marching natural hydrogen one office by one office by one office at this point. So would love the education, the message to get out with help from folks on this call, not only at the state level, but at the federal level.
Okay. One last question. I'll bring it in from Oakley Turner. And, this is the idea that hydrogen production can be very fast, that Mary brought up. And what are we looking at in terms of subsurface micro communities? This is one that I'll bring up, I'll address, is that in the subsurface, the vast majority of naturally occurring hydrogen is consumed by microbes. It is the key source of it. Or it's consumed in the alteration of hydrocarbon species in the subsurface. Engineering around those microbes is going to be very important. And, some of the questions come back to say that I heard a good quote from somebody who was talking about hydrogen and said, if you're producing hydrogen very fast, you don't worry about the microbes. If you're letting the hydrogen sit there, then you have to worry about the microbes catching up with it. I think it's the ability to flood the process going forward. Okay. What I need to do now is we're coming up on time. So I will turn it back over to Tatiana and Madeline for closing remarks.
Thank you so much, Doug, and the rest of the panelists. This has been a fantastic conversation. Really appreciate you sharing your perspectives. I think it's pretty clear to all of us now, if it wasn't before, that advancing this field is going to require both technical rigor and also a lot of policy coordination. And we hope that this report and this conversation will spur further dialogue and perhaps some more policy action and investment. I know we're at time, but before we close, I just want to quickly offer a sincere thank you to the incredible team at the EFI Foundation who made this project possible. Tatiana Bruce de Silva, Beth Dowdy, and Divine Medakalam, thank you so much for all of your efforts. And thank you everybody who joined us today and for your wonderful questions. If we didn't get to your question, we will follow up with you afterwards. So don't think that we are leaving you hanging, and have a great afternoon.